right, we are back with the second day about equations of circles. Today we're hitting 2 CCRSM standard. This is the other part of GPE 1 where we learn how to complete the square to find the center and radius of a circle given by an equation. So we'll talk about completing the square today. And then we're also going to re-hit GPE 4, which is where we use coordinates to prove or disprove that a given point lies on a given circle. All right, let's get started. Lesson 18 starts off with some opening exercises that reviews some concepts and skills with algebra that'll be pretty important for us today. I first want to define some words. The first word is binomial. A binomial is an expression that has two terms. That's why it's a binomial. For example, x minus 5 is a binomial. It has two terms, x and then 5. Also, 2y minus 7x is also a binomial. It has two terms. Now that's different from a trinomial where there are three terms. Okay? Now in A, we're asked to express this as a trinomial. And we're given a binomial that is being squared. So what does squared means? Well, squared means that thing times itself. So x minus 5 times x minus 5. And to expand this, I'm going to use what's sometimes called FOIL, but it's really the distributive property. So x times x is x squared, and x times negative 5 is negative 5x. And I just distributed the x into both the x and the minus 5. Now I'll do the exact same thing with negative 5. Negative 5 times x is negative 5x, and negative 5 times negative 5, a negative times a negative is a positive 25. And now if I combine like terms, I will combine these two terms, and I get x squared minus 10x plus 25. Okay, that's a trinomial with three terms. B asks us to express this as a trinomial, x plus 4 squared. Well, what does it mean to square something? It means you multiply it by itself. So I have x plus 4 times x plus 4. I will do the exact same thing by distributing both the x and the 4 into the other binomial. So x times x is x squared. X times 4 is plus 4x. And then this 4 times x is again 4x. And 4 times 4 is 16. I will again combine like terms and get x squared plus 8x plus 16. Now, in both A and B, we were squaring a binomial. And there's a pattern here that happens that will be very important for us to notice. Okay? The first thing is, where did this negative 10 come from? Well, it came from the negative 5 and the negative 5, which came from this negative 5. So in other words, the negative 10 came from doubling the negative 5. Does that work down here? Well, the 8 comes from the 4 and the 4, which came from doubling plus 4. So that middle term of our trinomial comes from doubling the number that's over here in the binomial. Okay? The second thing to notice is where the 25 come from. Well, it came from multiplying the negative 5 times negative 5, or multiplying this second term in the binomial times itself. That also happened down here with the 16, came from multiplying this 4 times itself. So those two patterns are very important for us. We generalize it over here. So if I have x, let's just say plus b squared, what that'll equal is x squared plus 2b plus b squared, meaning this middle term is by doubling this, and the last term is by squaring it. Now, if you want the negative version, it's x minus b squared is equal to x squared minus 2b plus b squared. All right, so the reason why this is important is because we are now going to factor. Okay, C asks us to factor the trinomial, meaning we are going from a trinomial back into a binomial that is squared. Okay, and we'll be taking this pattern, the pattern up here, and going back into from a 2b, figuring out what b must be, and then eventually we'll be squaring that and going back. Okay, and that'll make more sense as we go on with this. Okay, so we'll factor the trinomial. I'm going to look right here at this 12x. And I know that the middle term in the trinomial came from doubling something. So this must be 12 is double of what? Well, half of 12 is 6. And so it must be from x plus 6 squared. Okay, now let me double check that this number is right, because I didn't use the 36. Does that come from squaring 6? Well, 6 squared is 36, and so this is a squared binomial that is equal to x squared plus 12x plus 36 because it follows our pattern. We'll next look at letter D, and we're asked to complete the square to solve the following equation: x squared plus 6x equals 40. Now, when I rewrite that, I'm going to leave a space that I'll need to fill in later, equals 40. Okay? Complete the square means I want what's over here on the left-hand side to be a perfect square trinomial, just like we saw in C, where it factored perfectly into a perfect square. All right, so we'll use that pattern we saw earlier, where I will look at half of this number. So I want the perfect square to be x plus 3 squared. That's what I want it to be, and I got the 3 from half of 6. Okay? Now, in order to get that, then the number right here has to be 3 squared. Okay, we saw that again in the pattern. So 3 squared equals 9. So I had to have had a plus 9 right here. Okay, so x squared plus 6x plus 9 perfectly follows our pattern, and so that would be a perfect square trinomial. It would factor perfectly into x plus 3 squared. Now, hopefully, you're uncomfortable with what I just did, meaning that I added something only to the left side. And I'm hoping you're saying, whoa, 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 if you do that, it won't stay equal. And it needs to stay equal. So what I do to the left, I must do to the right. And I'm going to add a 9 to this side as well to keep it balanced, to keep it equal. Okay, so I have that, and that means this is equal to 40 plus 9 is 49. Okay, so I'm supposed to now solve the following equation. But truth is, that's the most important piece for what we're doing with equations of circles. Now, I could take the square root of both sides, and then I could subtract 3 and solve this quadratic equation. But honestly, my focus for today is hitting our CCRSM standard about completing the square to find equations of circles. So I'm going to leave this right here and not finish this problem, because I want to focus on the skill of completing the square. In example 2, we're asked, what is the center and radius of the following circle? And we'll need to complete the square for both x and y. So I'll rewrite this with some gaps. X squared plus 4x, and then leave a space, plus y squared minus 12y, leave a space, equals 41. And I've left spaces so that I can complete the square for both x and y, meaning I'll add what I need for it to be a perfect square trinomial. Now in x, I have x, and then I will take half of this. So half of positive 4 is a positive 2. And that again comes from that pattern we saw where this number doubled was the number in our trinomial. Okay, but in order to get that plus 2, then the number here has to be positive 2 squared, which is positive 4. But to keep it balanced, then I must add the 4 that's here over here, so that both left and right sides of my equations will stay equal. All right, now let's look at y. And y, let's see here, half of negative 12 is going to be negative 6. But in order for me to get that perfect square trinomial, what I needed right here was negative 6 squared, meaning negative 6 times negative 6, which is a positive 36. But to keep it balanced, I must add 36 to both sides. Okay, so I completed the square for both x and y. And what I get on the right side is 41 plus 4 plus 36, which is 81. So rewriting this, well, I guess I don't need to rewrite this. This is the equation of my circle. And the center we focused on last class will be, again, opposite negative 2 and a positive 6. And the radius, again, remember that this is r squared. The radius is the square root of 81, which is 9. All right, this video was about completing the square to find the center and radius of a circle given by an equation. Thank you for watching.